data. When we say information, we are talking about data that you have added some fresh to it. When we talk of data, what is data? Data is raw facts. Data is raw facts, such as furniture, chair, table, chalk, phone. Not, I mean, just like that, flat. So when you have data, there's nothing meaningful about it. But when you say Kofi is going to school, you have added fresh to some data elements, and you have processed it, and you have gotten information. So the official definition for information is what? Processed data. Okay. So when information modeling is nothing about data that you model for further activities. So when you have information, what do you get from information? You take decision with information. You use information to manage your environment or your organization. Okay, you use information to operate with. So you do work with information. And actually, you need information to be able to do the right thing. Even police say that before they will be able to persecute somebody or arrest somebody, they need information from the public. So information is very, very important. And so in our study, we are centering it around data. So we have at this point and in this course, we have already, I will need a kitchen. My kitchen should be this big. In my kitchen, I want to see this, I want to see that. I want a master bedroom. I want a separate toilet. I want that. These are elements that you have gathered, and you put it together. You don't draw it yourself. You can now consult somebody who can put the structure in a good shape that every mason will understand. The same thing applies to this area. When you want to build a database, the database is in use or is in place, you'll be using it. How do you get the database in place? How do you conceptually think about the situation? You have a business, you want to create a database to run your application, because of course, now currently, every application work under or work with databases. So if you don't have a database, you cannot create modern softwares. And modern software have databases. And so what we are going to do is basically as conceptually thinking about the data elements we will come across in specific domains. So you know the data that you get from school environment or data you will, and that is what we are going to do. We are going to look at how to gather data, put them in a structured approach so that we can build a database with it for the data, an organization to use, or for the domain users to use. So we start by saying that currently in our lives, I mean, we are in more like a competition. We are in a competition, especially if you want to, you are doing any business or you want to enter into any business, term as a market, and you that you are entering, you are just one of the competitors. Okay, so we are in a market, we are actually in a competitive environment. Data or information is the only key to use and there. And all this data, when you put it, you get the right information at the right time, you will take right decision. Okay. So the success of every organization actually is now more than ever dependent on its ability to acquire accurate, reliable, and timely data about its business or operation for effective decision-making process. So if you want to take any decision-making process, rely on actually what you have, the data availability, the data reliability, the data accuracy. So if you don't have these three major adjectives or properties of data, then your organization, I don't know how you are working with or doing things. So with that, it's also how do we get or acquire accurate, reliable, and timely data? The best approach is to organize the data in a structured format, and then to be able to get tools and you acquire the skills to deduce that information and get it used to support your operation. So database is a tool that simplifies the above, the accurate, the reliable, and timely data. So database system is a tool that simplifies the above tasks of managing the data and extracting useful information in a timely fashion. So if you are not able to create your database well, that's also another problem. So it analyzes and guides the activities of business purposes of an organization. The database is the only way that you can use to direct affairs in your organization. And it is the central repository of the data in the organization, because that's where every data element you will think of is gathered and stored. So information system is stored, information system, and it's essential for supporting the organization functions, maintaining the data for these functions, and helping users interpret the data in decision making is the work of database systems. So managers are seeking to use knowledge derived from databases for competitive advantages. For example, to determine customer buying pattern. If you have a good sales database where everybody who comes to buy from you or patronize your product can be tracked. And if that happens, then of course you can always reach your customers. You can give them information that will let them come back to you to purchase from you. If you are there, they send you information. Coming Wednesday, like what is this shop name? Melcom does. Every Wednesday they have sales. So if you are able to register with them and acquire their crab card, every Wednesday you can use it to fetch with a discount. Okay, even though there are rules attached, but there's some kind of discount you get. And people who want to acquire, if you can get 10%, and you want to buy a higher level expensive item, and you target that Wednesday, so that you have sometimes you have even 25%. So if you target those periods, you'll be able to save a lot of money as a client or a customer. So same to all the others. So there are so many information that managers rely on for further activities and work in their businesses. Support customer relationship management. So customer relationship, you want to give messages, birthday messages to your client. It makes them happy. When it's their birthday, they want people to wish them. If you wish them, you become one of their favorites. They will always be coming to your shop to buy. Online shopping, you also want to create a database such that you can utilize the online avenue where people do a lot of business. These days, a lot of people do not walk to shops to sell, to buy. So they want to rely on online shopping Okay, with that databases, you can do that. Employee relationship management. If your employee, you don't know much about your employee as to how many dependents they have, where they are, how to help employee dependent, so the employee will be comfortable doing their day-to-day activities. These are some of the things you can get through database implementation. So implement decision support systems. You can use your database as decision support system, whereby you implement structures from it to help take decisions, managing inventories, and so on. You want to know your inventory, if you are into sales business, you want to know the things you have, what and what you have, quantities you have, reorder level, so you don't go out of stock. These are some of the things, support structures that you will need a database to provide you. So to meet these changing organizational needs, database structures must be flexible to accept new data, accommodate new relationships, to support the new decisions. Always, your database must be reviewed, must be maintained, must be flexible to support the new data you generate in your organization and around you. Also to accommodate new relationship so that you can always get the right information, avoiding redundancy. Actually, database exists for the purpose of avoiding redundancy, avoiding inconsistencies, avoiding data independence. Having data independence and having consistent data and avoiding anomalies. Like when you want to update pen, you are updating chalk. All these things, when you want to insert a new product, is going to behave as existing product. These are anomalies that occur day to day that with a good maintained database, you can get away with or you can support with. So with the growth in computing technology and its application all spheres of modern society, now I don't see anywhere in our life that we are not using software. Even the AI we are talking about, it is built on databases. If you don't have a database, your AI, how can it reason? Where will it generate the train? How will it train itself to be able to do act in real time? When you have AI structures, it sense, it learns from existing and past records and be able to behave differently. So when he sees something which is closer to what he learned before, he'll be able to tell. That is AI. AI is a system that senses and learns. So it senses from data. It senses and learns from data, existing data that has things that has occurred already. It keeps knowledge instead, and then be able to move and show the right thing at the right time. So in our daily lives, everything we do depends on data. And the best approach to process data is databases to get the right accurate timely information. So we encounter several activities in our day-to-day life that involve interaction with a database. Every day we live, as at now, we are using databases. Sometimes we don't know. For example, bank database to withdraw and deposit money. We always go to bank. We don't go to our branches sometimes. We don't even visit branches. We just go to ATM and withdraw money. And this money we are withdrawing is not even coming from our branch. We belong to different branch. We are withdrawing from another branch. All these things are examples of bank database. It is database. Reservation systems. You want to buy a ticket. You sit online and you purchase a ticket. You expect the day of travel, your ticket to be known. All these things are where you, because whenever you are buying the ticket, it's the system or what you see on the screen. It is only the front end application. And that front end is actually talking to the database. The database to restore, I mean, to reserve your phrase and your space. So the next time or when the time is up, you are able to put at the right place. You bought this particular ticket, you bought it for this day, you bought it for this time, and you are going here, and so on. All this information are stored. Library database for searching of a particular book. These days, you don't just go and start searching one book after the other. We have passed that stage. We are using library databases. You can even use it online and offline. Like University of Ghana Library, you can reach it when you are offline. Since you people are distant students, find out about the URL for all these things, because now we have so many resources at the university library that you can support your studies. Books and research papers about subjects you are studying that can guide you. So these things are possible with the existence of what? Database systems. Supermarket goods, you purchase, go to ShopRite, you pick items, you bring it to the cash point. They are able to tell you the prices of each of the items and finally give you a total cost to pay. These are all kind of database activities. Without databases, you can't do that. So we know that databases is implemented with what? Database management system, and it's very essential for managing our businesses, government using it to operate and govern the country. Banks use it to manage their people's resources with them, to tell at any time how much you are left, to withdraw at any time, anywhere, and so on. Universities and every other kind of human endeavor are all using database system, which is stored with database management system. So it becomes a critical element of software industry. Okay, to support this requirement, daunting task to solve the problems of managing huge amounts of data, increasingly being stored. So these are the introduction aspects. What is the motivation? So motivation, why are we modeling information? Why do we even have to restructure or structure data element to a certain standard for a better use? Why? Okay, so in our lectures here, it will provide us motivation for studying. So what that means is we are going to think conceptually. So we are doing conceptual modeling, and present a brief historical and structural overview of information systems. So database management systems are widely used and are a major productivity tool for businesses that are information oriented. For a database to be used effectively, its data should be correct, complete, and efficiently accessed. For a database to be used effectively, its data should be correct, complete, and efficiently accessed. That's when you can get the right data. You do that by preparing the data well. In this class, we are going to use three modeling languages. One language is called object role modeling, and that is ORM. You have it's more like you are supposed to prepare the data well. How do you analyze data? You need to think. So this ORM will guide our thought processes, will help us to do proper analysis. And when we cover a bit of that, we will move on to entity relationship diagramming. And that is also one way that you design databases for relational databases. And in relational databases, you use the ELD concept to model your information system and structure it such that the development of the database, the development of the data systems will be easier. But you know that you as a designer, as a database designer or database architect, this is what you end up if you were in elsewhere in the world that jobs are so much available and different categories of jobs are opened. When you study conceptual modeling, you are automatically becoming what? A designer, database designer. So you think through the database and design it. But in Ghana, it's difficult to even get one job or the other. So everybody does whatever you get. But you don't know, you may not know. So it involves that the database is well designed. Designing a database involves building a formal model of the business domain, or the business domain can also be called universe of discourse. Universe of discourse. A business domain is hospital, it's a business domain. Education is a business domain. University setup is a business domain. Business, ShopRite sales or ShopRite shopping center is a business domain. It's about sales. And you know, database, like I said several times, is actually depicts what the realities is about. What happens in our real day-to-day life. That is what database works, shows. So it doesn't, you don't need the knowledge from anywhere. If right now you are asked to model a hospital, you know what happens in a hospital. You know there are patients, there are doctors, there are specialists, there are these people, laboratory, medication system, everything you know because of your exposure now. So that is the knowledge we are depending on. You are going to do modeling, but you are modeling based on real life issues, what is occurring in a specific domain. And of course, if you don't understand that domain, we also have another aspect that somebody who call himself domain expert will come in to assist you. So anytime you are in an environment to model data, you are not familiar with that environment, you will need help. You need the help from somebody who is a guru, somebody who has thoroughly studied that business or that organization and will be able to help you. The person who is conversant with that domain, who can guide you, will help you. So normally when you are done school and you are employed, you will be working under people. Sometimes you only the person who has the technical know-how, you need to know how to structure and what to structure. The same thing, they know what they do. And the expert, the domain expert or the analyst you get, the business analyst, that will be of your support, knows a lot about the business and how the business functionalities work. So he or she will be feeding you with this information, which will help you to do the proper thing, to understand it better, to put the elements in a proper shape, the data elements. So you require understanding of the universe of discourse. There's no doubt about it. You can't just jump in trying to model a place at something business or some organization or some domain work that you have no idea. So when it happens like that, you get support from the domain expert, the person who is a guru, the training manager there, or the expert that is involved. So that is more of That's the universe of Dcit. And so like I said, one modeling we will do, we say it's called object role modeling. It simplifies the analysis and design process by using natural language. Okay, it uses English. It uses English. It is, I mean, that is what you are familiar with. So it is simple. It is a modeling language that do small things. So you get a certain report or a certain output, and you are asked to model. Okay, and that is using ORM to do that. It is the easier. It's the simplest modeling language we can use. So object role modeling simplifies the analysis and design. And like I said, the first part of every modeling, okay, every building a system. In this case, we are designing a system. Either it's a legacy system we are redesigning, or a new fresh system, database system we are working on. Object role modeling simplifies the analysis. There involves analysis and design. The analysis and design is by understanding what happens. When you are doing analysis and design, the end result is requirement gathering. You use that process to gather requirements for the data element from the domain you are designing and analyzing. So the analysis process, by using natural language, it makes it simpler. So ORM, we say, is quite simpler and intuitive diagrams and examples, and by examining the information in terms of simple elementary facts. So that is one language we will soon tackle. ORM, object role modeling. By expressing the model, to do that, you express the model in terms of natural concepts, such as objects and roles. So you are given a certain diagram or a certain interface. It can be an input interface or output interface, okay, of a certain form, and you are asked to model it. And this is fact-oriented. We say that in doing object role modeling, you are doing fact orientation. Method provides a truly conceptual approach to modeling. So because it's fact-oriented, it is supportive. It is cheap, easier to work on, understand, and utilize. It helps you to get conceptual approach. Adam, hello, please mute yourselves. Mute yourselves. So apart from ORM, that is fact-oriented, we also have other languages like ER modeling, entity relationship modeling, ER modeling, which is very common, utilized a lot of places, especially in relational database design. And that one is a bit bigger concept in the sense that while ORM is looking at subjects or domain subjects per subject, because we say that even in modeling, you break the various concepts or functionalities sorry. In modeling, you normally break the functionalities into the subdomain, and then you take it one subdomain at a time. And then when you are done, you integrate them. And so we'll use another language called ER modeling, which handles modeling from top-down approach. Why ORM will be is more like bottom up. It gets the reports and it works through to design a model. So ER and UML, and also another language we will use is UML, Unified Modeling Language for Object-Oriented Modeling. We'll show examples and also do some work in that. Object-oriented modeling, ER models are typically more compact than ORM models. They are arguably less suitable than ORM for formulating, transforming, or evolving a conceptual information model. So we will use these three languages, ER, UML, and ORM. ER models a UML class diagram. In UML, we will only model with the class diagram. UML is for application, object-oriented application, but aspect of it handles the data modeling. And that aspect is the class diagram. We will use one diagram of UML, Unified Modeling Language, which if you have not studied it, you will study it under software engineering or system analysis and design. I don't know whether we ran that course again, but there was a course like that which has turned more or less to software engineering. And so UML is one aspect. We will make use of one aspect of UML called class diagrams. Okay, and in ER to entity relationship models. Okay, they don't use natural language as such. Why the ORM uses natural language? Okay, it's not simple. It has a little bit of compress. So we'll do the ORM first. So role-based constraint are less stable. ER and UML models better highlight the major features of a domain being modeled by representing currently less important features as attributes. So when you are doing ER and UML model, you distinguish between aspects, some data that are not really important, which is the characteristics of the data itself as attributes. And that's what we know, attributes. We know attributes from our last semester course. So ORM is used as our basic conceptual modeling method for the next 2-3 weeks before we move on to other ones. ER models and UML class diagrams are useful as well, especially for providing compact summaries, and are best developed as views of ORM models. For database application, conceptual models typically need to be mapped to attribute-based logical and physical models. So ER models provide designs that are closer to relational database structures. And so that's why we'll see that from that aspect. For object-oriented application, UML models can incorporate implementation details as well as behavior and deployment aspects not covered by ORM and ER approaches. So that's also the positive side of UML. And so a lot of programming tasks are coded mostly in third-generation languages such as C+ and Java. And then fourth-generation database languages such as SQL are declarative in nature, enabling users to declare what has to be done without the fine detail of how to do it, and are set-oriented rather than record-oriented. Fifth-generation languages such as Concar enable users to query conceptual models directly. So these are some of the motivation we have. Okay, we know the database types we have had. The hierarchical type, the network database systems, relational database systems, and so on. So now we are back to starting the information. We've seen the motivation. We see why we even need to actually model information. and what it is. So now modeling, what is it? How do we start? Modeling an information requirement for any business domain in a way that can be easily understood by the business users. Automatically generate a database structure to store that information. So modeling the requirements. Modeling is information requirements, okay, of a certain business. So you can put structure in place and be able to help the database developers to develop the database accurately. So we know what information models are. They are normally called data models. And that means information has already added semantics or meaning to the data we have. So which may be just a bunch of numbers or character strings. So example, you have S and Y. And you say S is 10, Y is 100. S 10, when you stand there and say 10, 100, it's data, nothing much, nothing much. But when you come to B, you can say S is 10, Y is 10, 100. What does that imply? Nobody will make meaning to it. But when you come to B, like B, where you say the number 10 is a square root of 100. Okay, it makes sense. It makes sense. So you have added some processing to it through a mathematical concept, which everybody understands. So to do that, so that people will understand, everybody will see the data and make meaning out of it and do further processing with the data. So another example, you have patient number 10, temperature 100. What kind of thing is that? You have patient number 10, temperature 100. Who will understand? You know that it's talking about the patient's temperature, yes. But 100, what kind of 100? So if you do further processing and you say patient number 10, your temperature is 100 degrees Fahrenheit, then it makes sense. So you have added sense, information. You get information out of the data. You have modeled the data well to make meaningful information. So every doctor knows that if your temperature is 100 degrees Fahrenheit, they know what to do for you. But if you make it 100 flat and then I misunderstood it and say, hey, we are in Ghana, and you are talking about 100 temperature, that means the person is almost gone. Your temperature is 100 degrees Celsius. So if anybody misinterprets the data, it can kill, it can destroy. That's why when you are modeling, you need to be careful and think. This causes more data analysis than writing and specifying. It's more brainy. It's more for you to think through the data elements and to deduce it and make meaningful impact to it. So take note, we have to think. We have to understand the data area, the domain that the data is being generated from. Like when I said temperature 100, you already know that the domain that is talking about temperature measurements. Okay. So the data model is a cornerstone for every information system. If you can develop any beautiful, understandable information system, you need to do data modeling. The data, because what is information? Data, process data. And actually, to create information system means you need to develop a software. And that software, first thing you need is what are the data inputs? It's the data input that gives you direction on what to do next in terms of processing. And that's where you have to think. When you see the data input, immediately your mind should know what it is about. Okay? While you are also thinking about the modeling structures You are actually thinking about the data itself, the kind of things that goes along that data that you can bring on board, the constraints that we say it that can affect it in that domain. Every domain has its limitation. Every domain has its rules. And sometimes the domain also tells you what they do. In this place, we have a law that we take only one email address. Of course, people have so many email addresses. Some people have Yahoo address, they have Gmail address, they have their workplace address. But based on what you are doing, you say you limit your staff or your employees to have only one or bring along only one email address for storing on their behalf. Based on what you are doing, some organizations will also want to know based on what they do, because if they do things that is about security, then they want to know you better. You that you are working with them, the employee. Please mute yourself. You, the employee, they want to understand you and know you better so they can work with you. So in that sense, you, the employee, they will want to know all your information, most of your information, such as the different email addresses you have, and store all of them. So when they do that, they are able to use it well and get what they want. Okay, so this is what we call business rules. So every business has its rules. The domain tells you the rule. That's why before you can do a better information modeling, you should understand the domain. And if you don't understand the domain well, then you need to fall on a domain expert to guide you. Okay. So information, because it describes the entity, so information is the cornerstone for every information system. Is data modeling, because in data modeling, your first step is to know the entities that the system will create and maintain during the system lifetime. The entities, the subjects, that's the major aspect of what we are going to do. The subjects, the entities. So data modeling is a technique. It's a technique for organizing and documenting a system data. Data modeling is sometimes called database modeling because a data model is usually implemented as a database. You need system thinking, like what I've said. In the analysis session, you need to think. It's the application of formal system theory and concept to system problem solving. Okay, so you also know that what is a system? A system is a set of elements interacting together, which has a boundary. So that's the domain I'm talking about. There is a limitation to it. There's a boundary to every setup, every system setup. It consists of things that works together, that interact with one another, okay, and produce outputs. And you all did depict data in terms of entities and relationship. Entity relationship diagramming, that one of the language we'll be using. It will depict the data we have in entities and relationships, which are described by the data. What are these data elements? When we have students, we can finally say that student is an entity. It's a subject of a school. Okay, it's a subject of a school. Faculty is a subject of a school. Do students relate to faculty? Yes, students are taught by faculty. So that is the relationship that between the two of them. These are some of the things we are going to understand and use. So basically, modern a typical enterprise data. You have enterprise view, and then we have the production system, okay? So we have corporate strategies and goals that will be applied. That's what we call the business needs. Okay, the conceptual data model will map plus the business needs, will give you the view of the enterprise. And of course, here is maintenance, logical model. So in a typical data setup, these are the three levels: the conceptual model, the logical model, and the physical model. In the physical model, that's what we studied last semester, both the logical and the physical. And so this semester, we are going to concentrate on the conceptual data models, where you need your business needs, that the domain, to be able to create corporate strategies and goals and stuff like that. So requirement gathering is one major thing we'll be focusing on. And in the process of understanding how the data is organized and identifying the relationship that exists between entities, you can discover most of the functionality that the system will satisfy. So business area of data modeling. So the data model of a business area tends to be relatively stable. Compare, for example, to the set of operational procedures or organizational. When you finish the business data and model it, it's standard, like architect designing a house. The plan will change when you want to add something small. It will change a bit, but it is more stable, okay, than normally the operational procedures and organizational structure, okay, which can change frequently. Therefore, basing the implementation of the future system upon a well-defined data model is a good first step towards the development or developing a system that meets the real requirements of the users. So data model is a good thing for business. The techniques and approaches. Two techniques are used interchangeably to model the data of a system. Entity relationship model, or what we call ERD or ERM. And data normalization is also another way to do that. Data normalization is entity relationship modeling is top-down approach. Data normalization is bottom-up approach, and we'll come to that later. So in ERM, we also have what we call extended ERM. Extended ERM. So these are all concepts and structures we'll study. Aims at identifying the entities. In all that you are trying to solicit or elicit the entities from the concept or from the domain. So that is first thing, you need to know your entities before you can start modeling. The mother of the modeling approach or processes is built on entities. And that is when you are doing ER modeling. And when you are doing what we call object row modeling, is also built on what? Object types and value types. Okay, because that is fact oriented. So that is also another way. Normalization makes the data model created using the ER more robust and extend the life of system based on the model. After you have built your ER model, you can use normalization to normalize it, to make it more, to actually make it more robust. That is, for it to be accurate. Avoid all redundancy, eliminate all redundancy. Normalization is a big process that we will finally also study. So there are two techniques go hand in hand and should be applied conceptually during data modeling activities. These are the two techniques: EL modeling and normalization. So approaches to data modeling, two approaches to data modeling: top down, bottom up. So top down is the ELD, where you start from the scratch on a concept, business concept given to you. And the bottom up is when there's already a database set up and there will be a way to redefine it. And so you have something in place. You are now redefining it based on some rules and structures of normalization. So this is a top-down approach, and this is a bottom-up. In the top-down approach, you identify the entities first. Then you discover the relationship, and then you define your attributes. And in the bottom up, you collect the data. Then you analyze and synthesize the data through the normalization process. Then you will define attributes for the individual entities, and then you use the attribute to support your relationship, discover the relationship, and then you finally come out with the different identifying the entities concerned. You finally come out identifying the entities concerned. So this is what you do in the top down and in the bottom up. You have data. The data you analyze and synthesize before you can get your attributes well defined, and then you discover the relationship and identify the entities. In the top down, you look at the concept, identify the entities, then you look at how do these entities relate, you based on principles and knowledge. Then you also define the attributes, which are the characteristics of the entities. So that is that approach. So now, conceptual data modeling. Conceptual data model. You have to base on principles. You will need graphical languages such as OLM, ELM, the notation, the specification aspect. Then modeling. You would think modeling is analysis and design to gather requirements, and then you apply your data constraints based on the domain. The constraints are data limitation, things that are not acceptable, things that do not work for this and that, based on the domain, the rules and the things that you are not supposed to do. So under principles, the main approach is the object-oriented. So first of all, when you say a class, it's also called entity set, and it's also called object. So entity set and object will be the same. In a typical object-oriented modeling, such as using UML class model, the relationship, we call it association. And then in a object role model, the relationship, we call it role or relation. So in all the three, like what we call class in the object-oriented or UML, we call entity set in ERD, we call object types in what? In ORM. When we say data member, which is attribute in ELD. That is, data member is a member of a class. So in UML, we say data member. In ELD, we say attribute. And in the object role model, it's a property or value. Okay. So instance is entity and occurrence. So this is the different principles we'll be basing our modeling on. And as we start, you'll be conversant with it. Entity relationship model, first of all, you identify your entities and you specify the entity in square rectangular box. So as it is based on what we have shown, the diagram, we have shown two entities. One entity is called customer. The other entity is called accounts. And this customer, we are saying, even though it's an entity, it is in the sense of the entity relational model, it's an entity set. It is an entity set that it's not talking about one customer. It's talking about all customers in that domain. So if you are talking of a business, this kind of online business accounts, or yeah, you have accounts and or a bank setup, okay, a bank setup. So we have customer and we have accounts, and they relate. How do they relate? So we have, first of all, the overs are the representation of what? The attributes of a customer. So we have identified 4 attributes there, 4 to 5, but we have separated 1 to the relationship end. So we have what we have drawn here. We use a certain notational structure. So there are different notational structures we'll be using. We have different notational structures. Some of the structures, you will have a diamond shape representing a relationship. So this is customer and account relationship. So it is represented in a diamond shape. And then we have account. So we have just identified minimum number of characteristics here. Account has account number and balance. Of course, that's common. And then we also have customer, which is the customer name, social security number, and customer city, customer street. Okay, so you see that this is a line different from the zigzag and different from the slightly shows. It all talks about the notation. So the representation also talks about what you are doing, the domain you are working from. So take note. So we have entity set customer, entity set accounts. We have relationship, okay, a customer relate to account. And it's a customer that open accounts in a bank. So basically, by looking at the data element here, this is talking about a banking institution. That's where you have to analyze and synthesize. This will be equally good at a banking institution and other domain. So you have to first fish out the domain. And when you fish out, that is where the real issues of how to do that comes in. So anytime you see the bank, if you haven't even worked in a bank before, at least you understand some banking principles. You know that to actually be part of the bank, you should be a customer and you should open accounts. So that is at least something basic you will know. And so you bring that on board here and you see that a customer opens accounts at what? Or a customer owns accounts. Okay, so that is the relationship between the two entity sets and so on. So we have object role modeling here. We have relation and property. So we have students enroll in a subject. Okay, student is given textbook. So you see that this is well explained. This is more like English. It's talking about students who has a name and address and a subject by name. So the subject can be computer science or information modeling as a subject. So student will enroll in information modeling, and a student is given textbook in information modeling. So these are all things, when you see it, you should bring your mind to deducing what it is, which area can it be operated. So we have object role modeling here, where we have employee who has these properties or these these values or instances. So we have these, and it tells you that P here is just by the notation that is used. P here is what? It's a primary key. Employee name, spouse, and the spouse has a ranking of 0 to what? Star, which is many. In 90, when you see star, most, especially databases, is talking about many. So all these things we will explain later. So employee represented by employee number has employee name. Okay, well, if you have to model what is here using object role modeling, you can get something like this. Employee, so you see, you are even modeling all the attributes, and the attributes are employee name and sport. Okay, and so they are more like object types. So employee number, employee identified by employee number has employee name. And so when you see a dash or a dotted rectangular box in object role model, it means it's a value. It's a value. Employee is the object type, and this is the value. Same as sports. Sports has object type. It's an object type which has represented by a name.
Hello, madam.
Yes.
Madam, please, can you go back to the this site? Please, you said when you see the boss that is tick, 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 is the employee name.
The employee is the entity. You see, the employee is on top. Is the name. The boss has division. It has been divided into two. And the top is the name of the entity. And then down is the characteristics or the attributes of the entity. Actually, in object role model, we don't say attribute. We say value. Okay. So these are the attributes, the properties, and they are given by value. So you, in modeling this, it's you that has to do which one will be the entities. And okay, so you are going to moderate this, and this is the outcome. The down figure is the outcome in object role modeling. We will learn more that will bring us to this side, don't worry. But for now, I'm just illustrating the languages. This is an object role model language. The language tells you that in object role model, you look for the object types and the value types. And so we see one object type called employee, which has been identified for us. It's on top of the diagram. And so if you have employee and you are modeling it, how do you speak it? And like I said, in object role model, you do speak it. It's the elementary fact. So you speak it in English. So you base on the things you've been given. Don't say they are attributes. In ELD, they are attributes. In object role model, they are values. They are examples. So, but as we gradually move, you understand some of these things well. Don't worry. This is just illustrating languages. Okay, so the ORM language, we will have employee, because it's the object type, it is solid rectangular box. But when it's a value, it is what? Because it is a constant. Let me say, when it's a constant. So we have employee name. Okay, employee name, it's as it is, it's a constant. So, but we have employee number as primary key of employee. So that's why in this place we say the employee, and that's why you even see the round violet thing attached to the employee. That's indicates what a primary key. And then we also have to give rows, relate them. How do we relate them in the entity relationship diagram? You will relate them. Here, you will relate them by giving them roles. So based on what you see, how do you model this? Nobody is telling you this is this, but you analyze what is here and tell us what it can be. But gradually, we will learn structures that will help you. But for now, when you analyze this, you can always say that employee has employee name based on what we have. An employee is referenced by employee number as its primary key. And it also employee praise sports. And the sports are many. So that's why it is not a value, but it is object. Because when you talk of sport, it has 0 to many sport, different sports. So each sport will be identified by the name. So it becomes an object type and not a value. Based on what you've been given, this is all you've been given from the organization to model. So you have to interpret this and through your analysis and design and come out with what you have. I hope it's okay.
Yes, please. Thank you so much.
Okay. So the other language is the UML, which is the class diagram. Okay, a class with instances, association, and property. So the class is the student. It has instances, it has association, and it has property. The association is nothing but the relationship. So in ELD, we say one entity relate to the other. In UML, we say one class is also associated to another class. So we use these keywords and know the differences. So we have the student class and the subject class. And the student class has a student name, family name, that's the last name, and address. While subject will be subject name. Of course, we are limited in terms of, we are not bringing all attributes here, just illustration. So we say student enrolls subject. Subject is enroll. Oh, what is this? Okay, so it's the way we are. So you read it like a student is enrolled by subject. Subject enrolls student. Subject enrolls student. Then that is what you have to add there. You need to create this association. When you have these two entities, how do they relate? How do they link? How do they associate? So you will know that students normally in a typical school, every school, a student has to be enrolled in different subjects. So the subject is the course you are doing. You have to enroll in it first. And then the subject, that's one relationship or association you can identify. But we will simplify things as we move along. And subjects enroll students. At least subjects, you find students in subject enrollment and stuff like that. So this is also in UML, the class diagram that we use, it has 3 divisions. The first one talk about the student, the second one talk about the characteristics, the last one talk about sometimes the primary key of the. So in conceptual model, first goals, starting from the dictionary and the rules that this model tries to reveal, the relations among the data and the
Hello,
interaction.
madam.
Hello?
Madam, please, can you go back again? Sorry for interrupting.
It's okay. Okay. Is it here? Is it here or I should go back again?
Please, yes, yes, here. Say, Madam, please, at the down, I can see that there's has the plane
The
star.
star.
Yes, please. What does it mean?
For now, I will explain that. I don't want to confuse you. So
Oh,
it's just illustration of student family name, student teacher's name, student mark, room number, student name. So this is something like after your analysis and design, you have come across and you are supposed to model this. Okay. So today is introduction to information modeling. So that's why we are going through this basic stuff to familiarize ourselves with the course. It's the introduction. So it's next week that we'll start giddy on the various structures and learn them well. So at least, but this is more like knowing the content and then the things involved. So like we say that class, entity instance, association, relationship between entity instances, attribute, their properties. So these three things are important. The objects here, we can say they are the entity or the entity class or the entity types, the object types, and so on. How do you define an entity class or entity type? Okay, you give it a name, and the name must be a noun, like students, employee, employee. So you give it a name. Every entity must have a name. You define its attributes, like what we call student has first name, last name, address, gender, date of birth, and stuff like that. Then you define the rules, what belongs to the class, how the instances are identified in the class, such as what we saw here. So the rules are examples here, where the business rules, what happens, what transpires in the day-to-day work of the school in this case. So what belongs to the class, how the instances are identified in the class. Identify an instance. So name, attributes, attribute one, attribute two. If they are, so you give a name to the entity. So here the example is student. Then you give the attributes, the different attributes. So this one, the attributes are first name, last name, and address. So this is what you do. So we give, then association is what? Nothing but the relationship, association name. So the relationship name goes down here. Okay, and there is arrow pointing to the reading direction. And like I said, some places you have to, if there is association between two entities, we call it binary relationship. I don't want us to jump. And so if it's binary relationship, it should be read from both sides of the diagram. So we have forward reading and backwards reading. So that is why we see MM here. I mean, the arrow here tells you in UML, you don't do forward reading and backward reading. You have an arrow that points to the direction you are reading. So you give one association name and you point it. Whilst on the other hand, in the ELD, you have to give, this is not ELD. Here you have to give two, because it's binary, you give the forward narration or labeling, and then you give the backwards labeling as well. But in UML, the arrow tells you once, and that's all. So we have entity name, entity name, attributes, and stuff like that defined. So basically, example, student and class. So you see that student belongs to class. In a typical university or a typical educational environment, student belongs to class. So because I'm reading from left to right, see the arrow shape. The arrow shape tells you where you are starting your reading from. So here I have the name of the association has a mark. And so student has a mark in subject so and so. Okay. So the name of the subject tells the subject name. So the name of the student name, and so on. And has a mark. So mark is an integer. Okay. It is another table, another entity. Okay. So we look at identifier of an association. So we see that enroll to gets a textbook. Student get a textbook from this. So you see one to many now. Now it's not just star, it's one dot dot star, meaning that it is either many or one. It is not optional. The optionality is that there's always. And then here when it's just you have something missing. And these things we will learn them, the basic things we will learn them later. So that's what we call the cardinalities of an association. So it is 0 to 1, or every student can use one locker. So here when we say student and locker, and we say 0, 1, 0, 1, and the relationship, that is the association name, is use. So starting from left, because where the arrow is pointing, students so and so, who has a name or something, and this definition, that student uses locker. And 0 to 1, 0 to 1, these are all cardinalities. I don't want us to bother ourselves with complexities now. We'll have opportunity to learn these things well again. So you see this one, the reading is from right to left. So you see the arrow is pointing from right to left. So category consists of products. That's how you read it. Category consists of products. Okay. So like that. A person choose GP. Students enroll optionally in subjects. So this is how it's work. There's a lot of things I will bypass for now. Okay, so data modeling for database design. First, the objectives. Understand the concept of data modeling and its purpose. Some of them we have introduced ourselves to. Learn how relationships between entities are defined and refined, and how such relationships are incorporated into the database design process. Learn how ELD components affect database design and implementation. Learn how to interpret the modeling symbols. So what is a model? A model is an abstraction of a real-world object or event. So useful in understanding complexities of the real-world environment. So representing a model shows how things are done based on the content, based on how each shape is reading. So by reading the shapes, and the relationships, showing from the right to the the right position to the other. Give useful understanding. Okay, it's an abstraction of a real world object or event. Then data model is a diagram that displays a set of tables and the relationship between them. So model, and when we come to data model, we say it's a diagram that displays a set of tables, because every entity is a table. Every entity becomes a table in the logical modeling. So a diagram that displays a set of tables and the relationship between them. Okay, so this is a typical entity relationship model. This is a typical entity relationships model. It's showing how many entities. It's showing, says, 5 entities. The billing address, the customer, the order, the product, and the order detail. So this is how to get this into this, is where our mission is all about. We have to be able to have a business concept, deduce all the issues, plan it, and draw and label it as this. That's what all this the course is about. So how to use ELD to do this, how to use UML to do this, how to use ORM to do this. So like I'm saying, ELD is a data modeling technique used in software engineering to produce a conceptual data model of an information system. So ELD illustrates the logical structure of databases. Logical structure of databases. ELD development can use case tools, which is Power Designer and Data Modeler. So you can Google and learn on these tools as well. So employees whose database knowledge can understand a data model diagram versus a list of tables used as an effective communication tool. When you have a database diagram or a data model, it is also used for communication, because it communicates a lot of information to the users as well as the designers or the developers. So improve interaction among the managers, the designers, and the end users. It guides them. It tells them what is necessary, what is not important, how things should be done, and all that. That's what a data model does. And it is independent from a particular database management system. The database managers such as Postgre, SQL, SQLite, Oracle, DB2, and so on, they are on their own. They don't come in during this stage of conceptual modeling. And so it gives opportunity for you to also try stuff and manipulate stuff, even though the database implementation will finally be done by a certain database management system. So the data modeling revolves around discovering and analyzing organizational and users' data requirements. So requirement based on policies, meetings, procedures, system specification, etc. So identify what data is important. The data will be a lot, and this is where data analysis and data science comes in. So you identify what data is important. Identify what data should be maintained. So a major activity of this phase, the ERD phase, is identifying entities, attributes, and their relationship to construct a model using the entity relationship diagram. You need these 3 things: You need your entity, you need your attributes, and you need your relationship on this particular entity. So how do you find entities? If entities is the major thing in this modern data modeling approach, then how do we find entities? So we find entity and we say that entity is anything, either people, places, objects, events, etc., about which we store information. So to be able to know what is an entity or which is an entity, first analyze and think and say, is it about people? Is it about places? Or is it objects or events, etc.? So anything that in the organization or in the domain you are working that stores data or that can store data is an entity. Okay, example of an entity is supplier. Example of an entity is machine tool. Example of an entity is utility pole, airline seat, etc. Tangible entity is tangible. It's tangible when it is talking about people and products, okay, or places. And it's intangible when it's talking about events, activity, and stuff, but they are still entity. What we are doing now is teaching a class. It is an entity. It is an entity. So first you look for singular nouns. Look for singular nouns. So nouns are the major thing in the concept. You are reading to fish out nouns. You are reading to look for out for subjects and anything that data can be stored on or anything that has data. But a proper noun is not a good candidate, so take note. So entity instance. So know the differences from today. I mean, last semester we learned them as well. There are three characteristics, and how many instances? 1, 2, 3, 4, 5, 6. 6 instances. Instances are the values that you store in the database. They are the actual data. So your student ID, the data that will be stored against it will be all this. Last name, first name. So all these things are there. So you have student ID, it's an attribute, it's the column. The entity name is student. How are you saying student? Because out of student, we'll store student ID, we'll store last name, we'll store first name, at least we'll store data. And we have people who are students. So Arnold, Taylor, Simmons, Massey, Leith, Reith, and others are all students, where data is stored on them. So we say that entity instance are the entity values, the occurrence of the entity. So in this case, we have 6 instances, and we have the entity name there, as well as the column fields, the column or the attributes. So the attributes are the column-wise data. How to find attributes is the characteristics of the entity that is related to the domain you are working. It's not every characteristics or property that you'll be interested in. You are only interested in all the ones that you can store data on. So attributes are data objects that either identify or describe entities. So in other words, it is a descriptor whose values are associated with individual entities of a specific entity type. Relationship. We will learn all these things again. This is just an introduction part. We are going to learn all these things into details. Do examples for you to understand. So relationships are association between entities. Typically, a relationship is indicated by a verb connecting two or more entities. So when I show you the diagram of the diamond shape that connects customer and account, and it's given a name, it's a relationship. It's a relationship. Employees are assigned to projects. So the assigned is the relationship. It tells you that project entity and employee entity relates. Relationships should be classified in terms of cardinality. We have one-to-one, one-to-many, many-to-one, and many-to-many cardinalities. And so we all know that we don't implement many-to-many, but you break it further. You break it further. And when we talk of cardinality, the cardinality is the number of occurrences in one entity which are associated to the number of occurrences in the other. So here, so this example, we have teacher and subject. So teacher does what? Teacher teaches. Okay, teacher referenced by teacher name, subject's name. So teacher teaches subject. And then room. So make course. So our number. So the room is where the teacher teaches and all that. So something like this. But I will show you proper examples when we start. We have weak entity as well, weak entity and stuff like that. Oh, my commission. Okay, so attributes with relationship with cardinality is identifier. Identifier, you know that from last semester, it was mentioned, every entity or every table, entity becomes table, and every table has an identifier, which is the primary key. There are sometimes you have composite keys. So normally when you see identifier, it's one of the attributes that is underlined. So sometimes you see that underlined. So you have the entity name in Crowfoot notation. Crowfoot notation, known as IE notation. Okay. Crowfoot notation, you have a box like this. The entity has a name, so the entity name will be on top. Then the characteristics will be there. But the one that is a key characteristics, you underline it. So example is here. So we see that identifiers are represented here. Student entity. Identifiers here are, properties or attributes are 1, 2, 3, 4, 5. The student ID, the student first name, last name, date of birth, and major. But the student ID is underlined. That is the key field. The key field. And the basic cardinality we have in the IE notation, you will see 1-to-1. This is 1. This is 1. 1-to-many. Many is always in the Crowfoot. 1-to-many and many-to-many. Many-to-many. So we have these 4 symbols. So we have many-to-many relationship, M to N, which is normally not implemented. So you break it down to one to many, many to one. So always when you have such, we will identify some, we'll show you some and all that. So this is the interpretation. We have mandatory one. You see it's double. That is in this notation, not all notations. In this Crowfoot notation, we have one here, many. One means mandatory, so mandatory many. When we come to the O, it shows you optional. So here is optional one, and this is optional money. But the money and the ones, that one, so the money, the solid one will tell you mandatory. The zero attached is optional. Optional. So example, department and project. So one department has many projects. So when you think of two entities here, project and department, how do you relate to them? It's natural in real world. You see that project, if that's the company working on projects first. And if they are doing that, any project they get, they attach it to a certain department. That's a department that works on that project. So it can be an IT project, yeah. It can be an IT project, it can be a marketing project, it can be engineering project. Any project has a department that is responsible. So we say it's okay. Department manages projects. So this is what you can bring up. It's a relationship. Department manages projects. And how do they manage? The cardinalities is one department manages many projects, because in the life of the organization, a department does not sit there just for one project. I mean, this is natural and logical. So you conclude immediately that every department has many projects. So the relationship that exists between departments and projects is one to what? Many. And the keyword manages is the name of the relationship, the name. And so when you are able to create your entities, relate them, and attach your cardinalities and optionalities. So the one here simply means mandatory existence. One department will have zero or many projects. It's also possible that the department exists that has not handled any project before. But because we are talking in general and affecting, and it's affecting every entity, we will say that many, one to many, is the many is for some people. Some department will work on many. Some department will not even work on anything at all. So in general, we will say that the zero here is optional. Okay, so optional existence. So some will not have had any project at all in the life of the organization, or as at now. So in modeling it, you don't always conclude that every department will have many projects. Give allowance and show that there is sometimes a situation can arise that a department exists, but it has never handled a project. It hasn't got any project attached or assigned to them. So this is the basic interpretation of this small model. Department project. Department has a primary key of department ID. Project has a primary key of project ID. They are attributes. They are the attributes. And the entity name is the project here. The cardinalities here says that it's many because of the Crowfoot, but the 0 also make it optional existence. Whilst here 1 is solid 1, means that mandatory existence. So one department will has many or manages many projects, but one department too can be there without doing any project at all. So this is how it works. The entity name, the relationship name, and so on. Any questions? I think it's time. Any questions? So Peter Shen also has his diagram notation. So there are different notations. And here we're looking at business rule, and all the business rule is the way the company or the domain does things. So here we have one-to-many as well, student and professor. Okay, one student has many professors because you do so many subjects. So each subject is for one professor. Each subject is for one professor. By the rules that we saw, each subject is for one professor. So one student will have many professors. So entity in the Peter Shen, you see that there's not much interpretation, just one-to-many, 1 to n given, and you are done. So the name and the major are attributes. A student has a name, it has a major, it has ID number. And then here, professor has class that is teaching, the department it belongs, the name, and so on. So any questions? Hello?
Hi.
Hello? Any
Hello.
questions?
Yes, madam.
No question. No question.
Hello, madam.
Yes, madam.
No question. No question.
Madam, please, we don't have the slides on our site, on Sakai.
No, the slides, we are just treating it. We are now starting. Okay, you mean the previous year slides?
Yes, please.
Oh,